as you watch the video. No one missed the first number 1, monomials 1 term, binomial 2, trie 3, poly meaning many. And then to determine the degree of a monomial, it's the sum of all the powers. So if you had a little example like this, the sum or the degree of this monomial term would be 3 plus 2 plus 1, or a degree 6. Recognizing and gathering like terms, the next problem set. Remember, to be like terms, you have to have the same variables raised to the same powers. When you find a match, you simply add their coefficients together, and the coefficient is the big number in front of the variables. So here, 6xy and negative 9xy, giving you a negative 3xy. And then next up, 7x squared y, looking for a like term, would be 6x squared y. Simply add the coefficients together. And then finally, xy squared, and you have 3 distinct terms, so you would name this as a trinomial. They're all polynomials, but this can be given a specific name, trinomial, for 3 terms. Number 4, 5a cubed b squared c. Looking for a match, you need an a cubed b squared c. This does not have b squared. This term has no b squared. This term doesn't have the right power on the a. And then finally, a cubed. So here we have a match, and adding positive 5 and negative 1. Next, ab squared c, the next term, looking for a match there. ab squared c, ab squared c. And you can see in this particular problem, the coefficient is negative 8, and the coefficient here is positive 8. So they sum to 0, or you can think of them that when you add them together, you get 0. So moving on, change pen colors. I have 9a cubed b to the first, c to the first. So looking at the terms that are left, there is no match, so that remains exactly as it is without a change in my final answer. And then that leaves me with 2ab squared c. So I simply just copy that down. That's my simplified answer, combining my like terms. Once again, I have 3 distinct terms, so this is a trinomial. Number 5, m squared n, looking for a match. M squared n, right here I have a match, so I combine positive 7 and negative 6, leaving me with 1, a coefficient of 1, and you can simply write that result as m squared n. Then next you're looking for mn squared, and you have another match right here. So I have positive 6 and negative 5. When I combine those, I have 1 left. And then finally, looking for squares on both, I find a match. I just add their coefficients together, and the powers on the variables remain unchanged. So once again, you have 3 distinct terms, so you could name this as a trinomial. The little box with the properties in it, completing the properties. Well, the first property, write the base of x 1 time, and then you add the exponents. That would be n plus m. When the bases are the same, you add the powers. The next, write the base once, and then you multiply the powers. That's a little shortcut. And then the product in parentheses, you distribute the power to each factor inside the parentheses. So that's a to the m times b to the m. Just straightforward properties coming directly from your notes. Okay, the back page. Please correct all of your problems because we need to move on to new topics. Number 7, you could simply write the base 3 one time, then you add the exponents together, giving you 3 to the 11. Your calculator will take that and give you the number 177147. So that should have been pretty easy to do. Number 8 is very, very simple. The variable without an exponent it's implied that it's to the first power. You write the base of x 1 time, and it becomes 5 plus 7 plus 2 plus 1, giving you a power of x to the 15th. And then number 9, writing the base of n one time, and you have 100 plus 200 plus 300, n to the power of 600. Number 10, you can think of this as the negative sign inside parentheses. You could think of that as a negative 1. So I have a negative 1 raised to an odd power. And then I have the 3 raised to the 5th. I have m to the 4th raised to the 5th, so that's 4 times 5, and then n to the 5th. Cleaning all of this up, a negative number raised to an odd power remains negative. 3 times itself 5 times is 243. Please use your calculators to do that. The power on m becomes 4 times 5, or 20, and the power on n is 5. So take a second, make sure you understand what's happened there with that problem. A lot of people miss that one. Number 11, I'm going to clear the ink, so you may need to stop the video and write something down. I'm going to clear the ink and scroll up so that I can do the rest of the problems. Number 11, I have a negative number raised to an even power. You can think of this as negative 1 raised to the 4th, giving you a positive result. Next up, I have 5 raised to the 4th, and then x raised to the 4th. So get your calculator out, multiply 5 times itself 4 times, or raise 5 to the 4th power. You get 625 x to the 4th. So this is your final answer for number 11. Number 12 is a little bit different because the negative sign is not inside parentheses. So you could think of this as a negative 1 times 5 to the 4th times x to the 4th. The only difference is now the answer is negative 625 x to the 4th. So the only difference being the set of parentheses. Number 13, you apply the power to each, but it remains a power. So this is 4 cubed, or 4 times 4 times 4, not 3 times 4 for 12, which is the mistake that I saw. And then I have x to the 2nd raised to the 3rd again. So the simplified answer for number 13 is 64x to the 6th, not 12x to the 6th. And in number 14, it's the same problem type, only another term is involved. So this becomes 2 cubed, which is 2 times 2 times 2, not 2 times 3 for 6, but 2 times itself 3 times, which is 8. And then I distribute x cubed. I'm cubing it one more time so I can multiply. And then y is to the 1st, so in my simplified product, it becomes y cubed. Now moving on to the next term. This is 5 squared, not 2 times 5 for 10, but 5 times 5. And then I have x squared, and I'm squaring it again. And I have y squared, and I'm squaring it yet again. So that would be the long way of thinking of this. And then to simplify your answer down, 2 cubed is 8. The exponent on x becomes 9. The exponent on y is 3. 5 squared is 25. X to the 4th, y to the 4th. And now you take the 8 and the 25 and you multiply them together to get 200. You write the base of x one time and you add 9 plus 4. And you write the base of y one time and you add 3 plus 4. So your simplified answer for number 14 is 200 x to the 13th, y to the 7th. So this is how all of the properties come together in problems like 13 and 14, or excuse me, 14 and 15. Number 15 is exactly like number 14, except I have the additional, the negative sign. So you can think of this as negative 1 squared, meaning it's positive. Then next you would have 5 squared, which is 25. Then you have x, y, and z all being to the 1st power inside the parentheses. So when I apply the square, I have x squared, y squared, and z squared. And then my second term, I have 3 squared, not 2 times 3, but 3 times itself. 3 times 3 is 9. I have x squared, and I'm squaring it again. So that's 2 times 2, or x to the 4th. I have y cubed, and I'm squaring that again. So that's 2 times 3, or 3 times 2, for y to the 6th. And then z to the 4th, squaring that, giving me z to the 8th. So then, once you've applied the power to each factor, you multiply 25 times 9 for 225. Write the base of x one time, and it becomes 2 plus 4. Now you're using the first property. Write the base of y one time, and it becomes 2 plus 6. And then write the base of z one time, and your power becomes 2 plus 8. And your simplified answer being 225, x with an x raised to the 6th power, y takes the 8th power, and z takes the 10th power. So all of the properties coming together. Number 16, you're using each property, each piece, just like you did in 14 and 15, to create a pair of like terms, which you will then add together. So applying the first property, or applying the property to the first expression, it's 3 squared, x to the 4th squared, which is x to the 4 times 2, and y squared. The next term is squared. So you have 2 squared. X and y are both to the first, so they take the square property. And let's just clean up this side of the equation. This gives me 9, x to the 8th, y squared, times 4, x squared, y squared. I now multiply 9 times 4 to get 36, and my power on x becomes 10, 8 plus 2, and the power on y becomes 4, 2 plus 2. And now go to the other side of the addition symbol and use the same properties. 4 squared, I have x to the 5th, and I'm squaring that, so that's 5 times 2. So that becomes 16 x to the 10th, and then I have a negative sign, like a -1, raised to an even power, giving me a positive number. And then I have 1/2. Do scratch paper. This is 1/2 raised to the 4th. So you can think of this as 1/2 times itself 4 times. And if you get your calculator out if you need to do that, but 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So this is 1/16. So the coefficient coming out of this expression is 1/16. And then you have y to the 1st, and when you apply the 4th power, it's y to the 4th. So you needed to do a little bit of side work on that to figure out 1/16. Now when you combine here, you have 16/1 times 1/16. That gives you a coefficient of 1, x to the 10th, y to the 4th. So you've created like terms. If you have a pair of like terms, you simply add their coefficients together. And your final answer for this problem is 37, but the variables and their powers remain exactly the same. X to the 10th, y to the 4th has no change whatsoever. So I need you to print out a new copy of the quiz, correct your quiz, and turn it in on Friday for a homework grade. Turn it in corrected for a homework grade.